Hello, welcome to our channel for rprogramming. In this video, we will talk about probability functions in R. So in R, all probability functions take the form dpqr and an abbreviation of distribution. So here dpqr means one of these four alphabets will be chosen to do some operation for this distribution. And D for the density, probability density, P for cumulative probability, and Q for the quantile, and R for the random number generation. And probability distributions abbreviation here list almost all probability distributions that can be used in R. For example, binom for binomial, logis for the logistic, nom for the normal, and so on. For example, here we can normally distribute the numbers and plot them using ggplot2. So for x is a vector from -10 to 10 with a gap 0.2. So then we can use dnom x. So dnom means the density for the normal distribution of this x. So we can calculate the density for all these random variables in normal distribution. You can also use pnom to calculate the cumulative probability for the standard normal distribution with the random variable 1.25, and so on. So next we will show more examples in RStudio. So we first load library for ggplot2. Then x is a vector from -10 to 10 with the gap 0.2. Then y is dnom of x. So y is a vector of the density from normal distribution of this vector of random variables. So create a data frame with x is x and y is y. Then we can use ggplot to plot the relationship between x and y using a line function and with the label and a scale. So this plot shows the probability density of normal random variable from -10 to 10 with the mean 0 and standard deviation 1. You can also use pnom to calculate the cumulative probability of normal distribution for the random variable 1.25, so about 0.89. And you can also calculate the qnom for cumulative probability 0.6, and this normal distribution have mean 30 and standard deviation 8. So this random number is 32. You can also generate 20 random numbers from a normal distribution with mean equals 30, standard deviation equals 8. So these 20 numbers come from such normal distribution. So next we will use probability function for the uniform distribution. So first, we use R uniform distribution, R UNIF10. So by default, uniform distribution will generate random number between 0 and 1. So these 10 numbers are randomly generated from this uniform distribution. If we run again this function, you will get usually different results because of the random number generation. But if you want to get the same result, you can use set seed just in front of this function. So we set a seed 5, 6, 7, 8. Then run this function. Next, we set a seed again. Then run again this generation. You can see these two run will get same result. You can also download the source files from this GitHub link, and more videos will be uploaded later on YouTube soon. Thanks for watching and subscribing our channel.